Yesterday we talked about altitudes. Altitude means what? What's going to happen on an altitude? It's going to get higher and lower, right? It's going to make things higher or lower. How about on a period? What happens? It's going to, in a shorter time period, the greater the period, the shorter the time period happens. So as you multiply it by a whole number, it's going to make it maybe more, think of it as high-pitched. It's going to happen in a much shorter span. Okay? If you go into the half of it, then it's going to be more like a deep voice. Okay, it's going to slow it down. How about the phase shift? Phase shift. What was phase shift? A secret. Kayla, what was a phase shift? It moves it over. So we're taking a sine function, sine wave, and we're going to move it over slightly. Okay? Things we have to remember on those is what those actually are. Our amplitude, okay, is going to look like this. We're going to put something out in front of the function. Okay? So anything out in front is going to cause the amplitude either to go up or down. Okay, it's going to increase it or reduce it. The period goes within the sine, all right? And this creates it, the bigger this number goes, the faster this is going to happen. All right? If you go into a fraction, it's going to slow it down. All right? So you can think of it as high pitch, low pitch. And then the last one is phase shift. All right? And a phase shift just moves it over. So if we're working with a sine like this, it may slide it over a little bit. All right, with a phase shift. And the phase shift is going to be within the sine, but what we're doing is we're adding to it. So maybe I added pi over 2 to it. All right? So that creates my phase shift. What we're going to talk about today is when we start, what happens to your functions, your different functions when we start adding more variables into it. So it kind of, maybe even a quadratic formula, or maybe an extra x, something of that nature. What's going to happen? Let me pull this back up. All right, let's take a look at the functions here once. Let's say we were to add something with x squared in it. Okay, so basically what we're doing is we're squaring that out. Think about what happens when you go 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Notice how that number is getting larger real fast. Well, if we went x times x, all right, and we replaced one of those x's with a 2, it makes that period much quicker, doesn't it? All right, so as this number increases, the faster my periods are going to happen, the quicker it's going to happen as it goes out. The same thing would happen with cubed or to the fourth. It's just going to make it that much faster. It's going to happen within my periods. Now, what if we took the same equation and we put an x out in front of it? What's going to happen to it? Oh, yeah, because up in here I don't have anything up here. It didn't like that. There we go. Okay, if you notice, my amplitude starts to really increase as we get away from our zero, our origin here. It starts to get really big. What does that kind of look like? Kind of, yeah. Flux capacitor. All right. As you're approaching a point, it kind of almost is the inverse of as sound waves come to you and they go past you. All right. This is kind of the inverse of that. What's that? Okay. What do you have to do? Well, how do you see it? It's in red. Oh. What is it? What's it supposed to look like? Oh, okay. So you're looking at 3D. I see. Okay, these are lockers standing up. I gotcha. Sure. That looks good. Squint your eyes a little bit. Take them out of focus. Sure. This would be your lockers here going down the hallway. Nice. Okay. So what happens when we phase shift this? Yeah. Phase shift this by X plus X. Did it do anything? Didn't do a thing, did it? Why is that? Same X. So what it did is if we put pi over 2 plus pi over 2, it'd still be pi, right? Which would still be on the same graph. Sure, our point might have moved. Instead of being here, it's down here, but it's still on this same graph. And this graph goes on forever. Right? So, what you're going to do for this this assignment, it's going to be real tough. Because I got to see. I'll have to put a little lamp right here, huh? All right. Page 326. Page 326. Let's clear this mess. Page 326. Look at number 13 on there. Just take a look at number 13 on page 326. It's y equals sine of x plus, or theta, they say in here, theta plus 90 degrees. What is that? What is it? Tell me. It's a phase shift to what? What can I also say this is? Cosine. This is cosine of theta. All right. All right, let's see. 13 we did already. Let's do 17, 21, 23. Ooh, these are some good ones. Let's do 17, 21, 23. You're going to have to graph these. 25, 27, 29. Because I missed 19. You want to do 19 too? What I'm picking is the sines and cosines out of there. I'm not doing the tangents out of it. All these are sines and cosines. All right. Kyle. All right. Do number 32 also. 32.